Welcome to science class. Today we are going to learn about the groups of minerals, the properties of minerals, and how geologists identify minerals based on those properties. Last time we learned there are as many as 5,500 different minerals, and all of those minerals fit into just 7 different groups. The most dominant group by far is the silicate group. Minerals that are silicates contain silicon and oxygen plus any other element. 90% of common minerals are silicates. Examples include biotite, muscovite, olivine, pyroxene, feldspar, and quartz. Next we have oxides. Oxides contain oxygen plus one or more metals. If you're familiar with the periodic table, it's made of metals, nonmetals, and metalloids. Silicon is not a metal, it's a metalloid. So if any minerals contain oxygen, some metal, but then also silicon, it's not an oxide, it's a silicate. Iron oxide, which is rust, hematite, limonite, and magnesite are common oxides. Sulfates contain sulfur and 4 oxygen atoms, plus other elements besides silicon. Gypsum is a common sulfate mineral. Sulfides contain sulfur but no oxygen. Pyrite, galena, and cinnabar are examples of sulfide minerals. Carbonates contain carbon, oxygen, plus any other metallic element. Calcite is an example of a carbonate mineral. Halides are more commonly called salts. All halides contain a halogen element, which is the second to last group of elements on our periodic table. Fluorite and halite, which is the technical name for table salt, are examples of halide minerals. And then finally, there are native elements. These are different because they're just elements, they're not compounds. Diamond forms crystals but is composed entirely of carbon. Gold and copper can actually form crystals if they are relatively pure. Great, so those are the different groups of minerals. But minerals have specific names, such as the ones I gave you. So what mineral is this, and how do I find out? Let's get started. You're probably familiar with classification. We classify animals and give them unique names. A kangaroo and a Komodo dragon are pretty easy to tell apart, but a coral snake and a milk snake are much harder to tell apart. Minerals are the same way. Some are immediately recognizable, like pyrite. But 2 minerals may be so similar to each other that you have to examine them very closely to tell one from the other. And we do this by looking at their various different properties. 2 minerals might share none of their properties, or they might share all but one, but that is how we identify them. There is one guaranteed way of identifying a mineral using just one technique, and that is to acquire the mineral's chemical composition. But this is not something you can just do with your hands or with common tools. I can look at this mineral with a magnifying glass as close as I want, but I'm never going to see the atoms it is made of. It takes very expensive and sophisticated equipment to do that. I don't have tens of thousands of dollars of lab equipment, but I still have to figure out what this is. So what do we do? Well, first and foremost, we can look at the color. Because there are thousands of minerals, but much fewer colors, this doesn't usually help us out that much, but it's a start. Another problem is one mineral can come in different colors. Diamonds can be transparent, or pink, or yellow, or blue, or chocolate. Quartz can be clear, smoky, or pink, or, well, almost anything. Sometimes color is almost a dead giveaway. Amethyst is always a distinct purple, usually with a white base. The mineral citrine gets its name because it's orange and reminds us of citrus fruit. This doesn't tell you once and for all which mineral you have, but it does let you cross off 95% of the other minerals off the list sometimes. The absence of color helps also. Some minerals have virtually no color to them and are always transparent, like halite. Similar to color is streak, which is the color of a mineral in its powdered form. Streaking a mineral is the same as what you do when you write with a pencil. We just use porcelain plates instead of paper because porcelain is very tough. Most minerals streak exactly like you would expect them to, but some don't. Hematite looks like polished gray metal, but it streaks a deep rusty color. Hematite, magnetite, and galena all look incredibly similar, but this test could be used to single out hematite. Next we have luster. The luster of a mineral describes the way in which light reflects and interacts with it. Light may pass right through a mineral, or it might be scattered. It might be partially absorbed. It might be completely absorbed. It might be partially reflected and partially absorbed, or just totally reflected. Technically, there are only two types of luster, metallic and non-metallic. Metallic minerals look like polished metal. Pyrite and hematite are great examples. But there are many different non-metallic lusters. The next property of minerals is their crystal geometry. In the first video on minerals, I mentioned how the shapes they take on are dependent on the elements they contain and how those elements bond. We see this in minerals. Halite is made of sodium and chlorine, which can only bond at right angles, so it always forms cubes. Beryl, which comes in different color varieties, always expresses a hexagonal symmetry. Elements can do this too. We already know about diamond, which is made of copper, but I have some bismuth here, and it makes these amazing right angle formations. Minerals almost always form crystals, but most minerals are far too small to truly see their crystals. Sometimes one crystal grows out of another, which is called twinning. But again, no matter how large or how small, minerals form crystals. The gigantic gypsum crystals in the Nika cave in Mexico are hexagonal. These pyrite crystals are as small as 1/10 of a millimeter across, but they still form dodecahedrons. Hardness is the resistance of a material to being scratched. We know diamond is the hardest material on Earth because nothing will scratch it. But hardness does not equal toughness. If you hit a diamond with a hammer, it will shatter. The softest minerals, such as talc and gypsum, can be scratched just with your fingernail. Geologists place minerals according to hardness on a scale called the Mohs scale. By using materials to scratch your mineral, you can tell where it fits on the Mohs scale, therefore narrowing down what mineral it is. What I'm going to do now is smash some halite with a hammer. Normally, when a material breaks, it breaks into random pieces, but many minerals don't break randomly, they break predictably. You can see that all of these pieces of halite still have flat faces and form right angles. This is a property called cleavage. Cleavage means that when a mineral breaks, it leaves perfectly flat surfaces. Minerals show cleavage for the same basic reasons that they make crystals. It has to do with how the atoms are arranged and which ones they're made of. Some minerals don't have cleavage, instead they fracture, which means they do break randomly. Quartz fractures when it is broken. The last common property mineralogists use is density. Density is a measure of a material's mass compared to its volume, and we express it as grams per centimeter cubed. Sometimes you will hear density expressed as specific gravity. Hematite and galena look similar, but galena is made of lead and sulfur, whereas hematite is made of iron and oxygen. Galena is much more dense because it's 50% lead. By taking all of these different properties and applying them to a mineral, you should be able to figure out what it is. That is, as long as you have access to a data bank that has all the names of all the thousands of minerals. As for this black mineral, I don't actually know what it is. I think it's gadolinite, but it's hard to know without the proper equipment. And that does it for minerals. Next time, we will begin studying rocks, starting with igneous rocks. Thanks for watching.